Simplifying Algebraic Fractions with Tutor. Algebraic fractions are just fractions with algebraic expressions in the numerator and or the denominator. You can do all the same things that you would normally do with fractions, such as simplifying, adding, subtracting, multiplying and dividing. Algebraic fractions can be simplified the same as you would with ordinary fractions. Look for common factors between the numerator and the denominator. The only difference is your factors may sometimes involve algebraic expressions as opposed to just whole numbers. These are the beginner and the easiest types of questions that you're likely to see. We can start by drawing our line to represent a fraction and then focus on each number or variable of the fraction. So starting with the numbers 36 and 6, we can see that both of these numbers have a factor or are divisible by 6. 6's go into 36 6 times, so we put that at the top, and 6 goes into 6 once, so we put that at the bottom. Next, we have our x variable. If we write these in full as a product, we can see how this works. X to the power of 5 is the same as x multiplied by x multiplied by x multiplied by x and then multiplied by x again. And x to the power of 3 is x multiplied by x multiplied by x. You can see that both the numerator and the denominator are divisible by x times x times x. So we would cancel one from the top and one from the bottom 3 times. And you end up seeing that we just have x times x left as the numerator, which is the same as x squared. The shortcut would just be to do 5 take away 3 because we were dividing. So dividing leads to cancelling out, which is the same as subtracting. Finally, we can tidy this up because 6x squared over 1 is the same as 6x squared. We'll repeat the process for the second question with a few slight differences. Starting with 26 and 52, make sure you always identify the highest common factor. For example, both of these are divisible by 2, but the largest factor would be 26. 26 goes into 26 once, and 26 goes into 52 twice. Next, we'll move on to our variable a. Notice how we have a squared at the top, but there's no a variable at the bottom. That means we're unable to simplify this, so it just remains as a squared at the top. Moving on to our b variable. In the same way we did 5 take away 3 for the first one, because of cancelling, we can do the same for this one. The only difference being when you divide both of them by b times b times b, or b cubed, we'd be left with b squared at the bottom instead. So we can still subtract, but just make sure you start with the largest number, which is 5, and subtract the 3 in this case, leaving us with b squared at the bottom. Lastly, we have our c variable. It's important to note that c is the same as c to the power of 1. So in this case, we can start with the 4 in the numerator and subtract the 1 as the denominator, leaving us with c to the power of 3 at the top. Tidy this up by removing 1 and writing the variables a bit closer together. A squared c cubed over 2b squared. Next, we're on to the intermediate questions, which involve an increase in difficulty. The difference with these questions is we have more than one term separated by some type of operation such as subtraction or addition. We can still simplify these similar to how we did on the previous questions, but we may need to do some factorizing first to spot or identify the highest common factor from the numerator and the denominator. So the first thing we'll do is factorize 48t minus 6t squared into a single bracket. 48 and 6 both have a highest common factor of 6. We'll also be able to take a factor of t outside this single bracket. 6t multiplied by 8 will give me 48t, separated by a subtraction, and 6t multiplied by t will give me 6t squared. The denominator will remain the same. Because simplifying just involves looking at the factors of the numerator and the denominator, we can now just focus on simplifying these parts of the algebraic fraction. Similar to how we did on the first questions, 6 and 8 are both divisible by 2. 2 goes into 6 3 times and 2 goes into 8 4 times. Notice how there is no factor of s as the numerator, so nothing will cancel and will remain with s squared at the bottom, and t at the top will cancel with t at the bottom, leaving us with the bracket, which we'll still need to include on the top, so 8 minus t. Tidying it up, we have 3 bracket 8 minus t over 4s squared. For the next question, start by factorising into a single bracket. We won't be able to take a factor of 3 and 5 outside the bracket. We will be able to take a factor of a, and we'll also be able to take a factor of b. That means we'll be left with 3a and 5b inside the bracket. Focusing on simplifying the numbers, we didn't have numerical factors as the numerator, so we'll just be left with 7 as the denominator. A will cancel with a, and b as the numerator will cancel with b cubed as the denominator, leaving us with b squared written as the denominator. And lastly, the bracket will remain at the top, 3a plus 5b. So tidying this up, we have 3a plus 5b over 7b squared. On to the hardest types of questions that you can have, which often involve quadratics. These can be done in the same way as the intermediate questions by factorising, but you'll need to have some prior knowledge on factorising quadratics. Starting off by factorising the numerator. Assuming you know how to do this, we're looking for numbers that multiply to give us positive 10 and add to give us 7, meaning the factorised brackets would be x plus 5 and x plus 2. And for the denominator, we're looking for numbers that multiply to give us negative 15 and add to give us 2, meaning the brackets would be x plus 5 and x minus 3. These brackets are factors of the original expressions, so x plus 5 at the top will cancel with x plus 5 at the bottom, leaving us with x plus 2 over x minus 3. And for the last question, we're looking for numbers that multiply to give us negative 45, but add to give us 1. But one of these factors has been multiplied by 2, meaning the brackets would be 2t minus 9 and t plus 5. For the denominator, we have difference of 2 squares, meaning the brackets would be 2t minus 9 and 2t plus 9. If you found factorising these quadratics difficult, then you should really go and watch my video on that before attempting these questions. And 2t minus 9 will cancel with 2t minus 9 at the bottom, leaving us with t plus 5 as the numerator and 2t plus 9 as the denominator. Before you go, pause the video and see if you can spot or correct any of the mistakes with the solution shown here in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.